Bismillah ar-Rahman ar-Rahim. Alhamdulillah. Salatu wassalamu ala Rasulillah. And this is Major 2 of Calculus 1, Math 111, Term 222. Let us solve the major together. First question, use the definition to find the derivative of this function. Well, the definition of the derivative says that f prime of x equals the limit of f of x plus h minus f of x over h when h approaches 0. That's the definition of the derivative. When he says use the definition, you should use this definition. Well, f of x plus h, we have the definition of f of x. So to find f of x plus h, I just replace x by x plus h. So I'll have x plus h squared minus 2 times x plus h. All of this is f of x plus h. Minus f of x, so this is f of x. I have minus f of x over h. Okay, now I will simplify. Keep the limit there. X plus h squared, when you expand, you have x squared plus 2hx plus h squared. Expand, so minus 2x minus 2h, minus 2 is multiplied by these two. Also the minus sign, minus x squared and minus times minus is plus. All of this over h. Usually, all the terms without x would be without h would be cancelled. So x squared, you will find negative x squared here, and negative 2x, there will be a positive 2x here. So now you can take h as a common factor. So I have 2x plus h minus 2 over h. Now you have multiplication product in the numerator, so you can cancel. You cannot cancel h with any of these h's before because there is a plus and minus. But now you can cancel h with h. And the limit is there, keep it there, so you can change or replace h by 0 now in the final step. So when you replace h by 0, you get 2x minus 2. So that's the answer of the first question. Differentiate the following functions. Well, here you have a product, so you have to use the product rule. So the derivative of the first function using chain rule would be 5 times 2x u plus 4x to the power 4. And then you multiply by the derivative of the inside function. Derivative of 2x cubed is 6x squared plus 4. You should keep here parentheses because everything is multiplied times cosine x plus the first function as it is times the derivative of the second function. Derivative of cosine is negative sine. Also, you need to keep parentheses here. This would be okay if you want to rearrange it. If you want to write negative sine x times this answer is fine. Here to find y prime, I have len, and here there is product, division, square root, powers. So it would be easier if I use the properties of len. We know that there are some properties of logarithmic function. If you have ln A over B, then this would be ln A minus ln B. And if you have ln A times B, this would be ln A plus ln B. And if you have ln B to the power R, you can write it R times ln B. We use all of these properties to expand this logarithmic. This is one logarithmic function, one ln, and it will be expanded to more than that. So we will have ln x squared plus ln square root minus ln cosine. Okay, so you can write it ln x squared plus ln square root of 2x plus 1 minus ln cosine to the power 4x. And then you can use the last property to take r out. So you still can write it. So y would be 2 ln x plus half, because the square root is 2x plus 1 to the power half. Keep parentheses here, and you can bring the 4 out. And now you can find y prime easily. Derivative of ln x is 1 over x. There is a 2 here, so 2 over x plus half. I can write 2 here. Derivative of ln 2x plus 1 is 1 over 2x plus 1 times the derivative of 2x plus 1 using the chain rule, which is 2. And then derivative of ln cosine is 1 over cosine times the derivative of cosine, which is negative sign. You can finally cancel 2 with 2 and write it 1 over 2x plus 1. And here you can multiply the negative times the negative and write it plus 4 sine over cosine, or you can just write it 10. That's the derivative. Again, here we have product of two functions. So we will use the product rule. Derivative of cosine x squared is negative. Derivative of cosine is negative sine. And then you multiply by the derivative of x squared, which is 2x, using the chain rule, times cosh x, or hyperbolic cosine of x, plus cosine x squared as it is, times the derivative of hyperbolic cosine, which is hyperbolic sine. So that's the final answer. You can write it at the end, negative 2x sine x squared cosh x plus cosine x squared sinh x. Find the equation of the tangent line to the curve y equals at the point 0, 0. The equation of the tangent line, equation of any line, is y minus y0 equals slope times x minus x0. This is the slope point 4, or point slope 4. If you have a point x0, y0, and slope. Well, here in the derivatives, after we studied calculus, we know that you can call the point a f of a or y of a, because he said here y, the function is y. And we know that the slope is the derivative. So it's y prime at a times x minus a. Okay, if we call x0 a. So here, this is the point. So this is a, and this is y of a, or f of a. So the equation would be y minus 0 equals y prime at 0 times x minus 0. So all what we need to find is y prime at 0. So let us first find y prime. Well, y prime, the derivative, I have a product of two functions. So again, I'll use the product rule. Derivative of 2x is 2 times the other function, plus 2x times the derivative of the second function. Derivative of the exponential function is e to the power negative x squared times the derivative of negative x squared, which is negative 2x, using the chain rule. So now y prime at 0, I replace x by 0. E to the power 0 is 1 times 2, so I'll have 2 here, plus x 0, so 0 times anything would be 0. So y prime of 0 is 2, and the equation is y minus 0, that's y. Y prime of 0 is 2 times x, so that's the equation of the tangent line. That's the answer. Using the implicit differentiation, find dy by dx, which is y prime. So let us find the derivative of this equation. Here in the left-hand side, I have products. So I'll use the product rule. Derivative of y squared is 2y times y prime. Okay, because y here is a function of x, times cosine x plus y squared as it is. Derivative of cosine is negative sine x equals 2xy. Again, this is product, so I use the product rule. Derivative of 2x is 2, and derivative of y is y prime, plus derivative of 2y squared, that's 4y, times the derivative of y, which is y prime, and the derivative of negative 1 is 0. So that's the first step. And then the second step, all the terms with y prime, keep it in one side. Let us keep it in the left-hand side. And I have 2y here, and let me take this term to the other side. This is negative y squared sine. If you take it to the other term, to the other side, it would be y squared sine. And now you can take y squared as a common factor from the terms in the left-hand side. And the final step would be to find y prime or dy by dx by dividing what you have in the right-hand side over the coefficient of y prime. So that's the answer. Verify the identity. To verify this identity, I need to know the definition of hyperbolic sine and hyperbolic cosine. So the left-hand side, definition of sinh is e to the power x minus e to the power negative x over 2. That's the definition of hyperbolic sine squared. So you raise it to the power 2 plus cosh hyperbolic cosine. It is ex plus e to the power negative x over 2 and raise it to the power 2. So you take one side and simplify it until you reach the other side. Now, if you square this rational function, I'll have 2 squared 4. And now I need to find the square of ex minus e negative x. So let me write it like this. Then plus, I have 4 here. And I will raise this to the power 2. When you expand the polynomial, you get 3 terms. The square of the first term, square of ex is ex to the power 2, and then you multiply 2 times x. So it's e to the power 2x minus 2 times ex times e to the power negative x plus e to the power negative x to the power 2 plus here I have e to the power x squared, which is 2x, plus e to the power x times e to the power negative x times 2, plus e to the power negative x squared over 4, because I have the same denominator. So I can add these two fractions. Now, e to the power 2x plus e to the power 2x is 2e to the power 2x. And here, e to the power x times e to the power negative x would be e to the power x minus x, which is 0. So in fact, this will give you e to the power 0, which is 1. And this will give you e to the power 0, which is 1. This is not negative 2x. This is negative x. Okay? So I'll have negative 2 plus 2. They will cancel with each other. And here, multiply 2 times x, e to the power negative 2x. And I have another e to the power negative 2x here. So I'll have 2 e to the power negative 2x over 4. Now I can take 2 as a common factor and divide by 4 in the denominator to have 2. And this is actually cosh or hyperbolic cosine of 2x. Hyperbolic cosine of x, e to the power x minus e to the power x, plus e to the power negative x over 2. So when I replace x by 2x, I get this one, e to the power 2x plus e to the power negative 2x over 2. So that's in fact hyperbolic cosine of 2x, and that's the right-hand side. So that's the proof. Find this limit. Well, I have t squared below, sine 4t, sine 5t. I know that limit sine x over x when x approaches 0 is 1. So I'll have to use this fact. So I will write this limit as limit sine 4t over t times sine 5t over t when t approaches 0. T squared, I can write it t times t. And I can write this fraction like this, because if you multiply, you go back to this one. And now I can write this limit sine 4t. I need 4 here, 4t here. So the limit would be 1 because x over x is 1. I multiplied by 4 here, so I should multiply by 4 outside. And then plus, sorry, not plus. This is multiplied by limit sine 5t over 5t times 5 when t approaches 0. I can take the 4 out. And the 5 out. Now using the facts, so this is 1. Oh, again, I'm writing plus. It's not plus, it's multiplication. 5 times 1. So 4 times 5 times 1 times 1 is 20. And the answer is 20. The radius of a sphere is increasing at a rate of 6 millimeters per second. Rate of change is the derivative. So whenever you see rate, this means radius. If we call the radius r, so this is dr by dt. This is the rate of change of the radius with respect to time. It's equal to 6 millimeters per second. So this is the meaning of the first sentence. Find how fast is the volume of the sphere is increasing. How fast is the volume increasing with respect to time? This is dv by dt. So he's asking about dv by dt when the radius is 40. So at this instant where the radius is 40 millimeters. And he gave you the formula between the volume, the relation between the volume and the radius. So to find dv by dt, given dr by dt, I need to differentiate this equation with respect to t. So differentiate with respect to t, I'll have dv by dt equals 4 over 3 pi, this is just a number, constant. Definition of r cubed is 3r squared times dr by dt. If you cancel 3 with 3, then dv by dt would be 4 pi r squared times dr by dt. Well, r is 40, dr by dt is 6. Now, if you multiply by the calculator, you will have 38,400 by 40 square times, pi. And if you want to write, it's millimeter cube over second, because this is the volume. I hope you enjoyed. This was the last question. I hope you enjoyed watching the video. Thank you very much.